Today we'll discuss what a parametric function is, and we're going to find the coordinates, find the rectangular coordinates, and convert a parametric function into y as a function of x. First off, a parametric function is any of a set of equations that express the coordinates of the points of a curve as functions. And today we're going to be using the equations x equals t plus 5 and y equals t squared minus 3t. So first we're going to find the coordinates. We're going to make a table, and our first column is going to have t, which is our variables. Our second column is going to have our first equation, y equals t plus 5, x equals t plus 5. And our third column is going to have y equals t squared minus 3t. And our last column is going to have our coordinates. And we're going to be using the domain negative 3 is less than or equal to x, which is less than or equal to 3. So we're going to go all the way from negative 3 to positive 3, and that's going to go in the first column. Okay, first off, we're going to, our first equation is x equals t plus 5. So our first step is we're going to plug negative 3 into t. So we're going to have negative 3 plus 5, and this is going to give us our input. So negative 3 plus 5, which is 2. And you're going to keep plugging in your t into your equation. So for example, your second one is negative 2 plus 5. Then you'll have negative 1 plus 5, 0 plus 5, and so on. In our second equation, y equals t squared minus 3t, we're going to do the exact same thing. So for our first one, we're going to plug negative 3 into t. So we're going to have y equals negative 3 squared minus 3 times negative 3, and that gives us 18. And we're going to keep doing this. So as in our second one, which is negative 2, we're going to plug negative 2 into t. So negative 2 squared minus 3 times negative 2, which gives us 10. And you're just going to keep going down until all yours are filled up. And then our last column, which is our coordinates, you're just going to plug in input in the output. So for example, our first one, we got 2 and 18. So our coordinates are 2, 18. In the second one, we got 3 and 10, so our coordinates are 3, 10, and so on and so forth. The second thing we're going to discuss today is how to find the rectangular coordinates. We are basically we're using the same equations. We're just plugging them in so we can show how we got our coordinates from our table. Our first equation is x equals t plus 5, and y equals t squared minus 3t. So first off, we have to solve for t. So our equation is x equals t plus 5. You subtract 5 from each side, and that cancels out. And so our equation is x minus 5 equals t. So our second equation is y equals t squared minus 3t. We found out that t is x minus 5, so we're going to plug x minus 5 into every spot that there is a t. So we're going to have y equals x minus 5 squared minus 3 times x minus 5. So after you plug in a t, you're going to factor out. So we have y equals x squared minus 10. So now when we find out, now we're going to factor out our equation. So y equals x squared minus 10x plus 25 minus 3x plus 15. And we're going to combine like terms. So y equals x squared minus 13x plus 40. And this is our equation we're going to use to find the coordinates. The first one we're going to use is t equals negative 3. Here we have x equals 2. And wherever there's an x in the equation, that's where you're going to plug 2 in. So y equals 2 squared minus 13 times 2 plus 40. And then we're going to factor this out. So y equals 4 minus 26 plus 40. And you add this all together, so y equals 18. And if we go back and look at our table, we can see that our first pair of coordinates are 2, 18. We're going to do another example. We're doing the exact same thing. And we're going to use the points 3, 10. We already have the equation solved, which is y equals x squared minus 13x plus 40. And so all we're going to do is plug 3 into that. So we're going to have y equals 3 squared minus 13 times 3 plus 40. And we're going to factor it out. So y equals 9 minus 39 plus 40. And after we add it all up, y equals 10, which is, so our second coordinates are 310, and it matches our table right here. And as you can see, our first coordinates were 218, like we solved, and our second pair of coordinates was 310, like we just now solved. And today we discuss what a parametric function is, how to find the coordinates, and how to find the rectangular coordinates.